Okay, the following information will be a little bit of review for first period as we touched on it Wednesday. This will be new information for seventh period. We briefly talked the other day about complex and irrational zeros. One thing to keep in mind is that they are found in conjugate pairs, always, which means when we are given only one imaginary or irrational zero, that we need to remember that they come in conjugate pairs and write its conjugate pair as one of the factors. So we'll take a look at number one together, okay? It's listed as negative 3i as the zero. So I know when I'm going to write the polynomial function, I need to list the factor that would be associated with that zero, x, and then I switch the sign. So that would be the factor associated with that zero. But when I'm thinking about my theorem, the complex conjugates theorem and irrational conjugates theorem, when I have complex or imaginary numbers, they come in pairs. So I also know that I have x minus 3i as one of its factors. Similarly, this 0, square root of 10, would result in a factor of x minus the square root of 10, but it also comes in a conjugate pair as it's a complex or irrational 0, so therefore I would also have x plus the square root of 10. So before I do anything, I need to remember that if I have complex or imaginary or irrational zeros, that they come in conjugate pairs, or I basically switch the sign of each. From here, I'm going to FOIL it out. I'll work with I first. That gives me x squared. The reason that they come in conjugate pairs is you'll see that's negative 3xi. This would be a positive 3xi. And then this would be a negative 9i squared. When I combine my like terms and simplify, these two should always cancel if I've done it correctly. I'm left with x squared minus 9i squared. But I can recall that I squared equals negative 1. So I can replace this with x squared minus negative 9 times negative 1, which gives me x squared plus 9. Over here, when I perform my FOIL, I'm left with x squared plus x square root 10 minus x square root 10 minus the square root of 100. Cancel your middle terms as they cancel each other out. I'm left with x squared minus the square root of 100, x squared minus 10. Now I'm going to take the two binomials left and multiply them together. X squared plus 9, x squared minus 10. And this will result in x to the fourth minus x squared minus 90. That would be the polynomial function that has zeros negative 3i and the square root of 10. What I would like you to do is move forward and complete the rest of this worksheet. On the front, we're working on what we just saw the video of here. And then on the back side of your worksheet will be more practice with what we did at the beginning of the week as far as connecting and putting together the end behavior and zero behavior of graphs. This is all due and will be collected and graded on Monday.